Good evening, my dear NEET warriors. Welcome to the lecture 3 of your one-dimensional motion or motion in a straight line. We have already done what is velocity, acceleration, displacement, and how to calculate the average quantities for all our kinematic equations and how to apply them, and also vertical free fall motion. Now it's time to see what happens when acceleration is not constant. That is called the non-uniform motion. And also the graphical aspects with calculations like the slopes and the areas. With me, your Captain Shreyas, your physics master teacher out here on the Vedantu NEET English channel. Welcome aboard. I have been training guiding for the last 13 plus years, and here I am to guide you yet another year through your one of the most competitive NEETs ever, NEET 2026. Because we already have been warned by NTA in NEET 2025 that listen, boss, NEET 26 and NEET 2027 is going to be tough. So let's prepare right from the basics in detail classes with all your amazing teachers in pure English for physics, chemistry, biology, right? So let's begin, my dear warriors. And let me also say hello to all of you. And if you're new to the channel, please subscribe. Hi, Mira. Hi, Yuvani. Hello. Rajshekar, is the chapter motion in a straight line completed? No, this is the last lecture. All right. Uh, UNC, hello. Hi, he ho. Welcome. Please upload the video from August to December like chemistry, ma'am. Yes, there is a video coming up very soon. Hi, Ian Chekam. Yes, Lekshna, I will be uploading that right away. I mean, just in a day. Okay, you'll be seeing that complete plan from August to your, year end. Cool. Hi, Sai Priya. Hi, FF Knights. Welcome aboard. Good evening. Good evening. So, have you watched the lecture of basic maths from the channel only? At least you know it, maybe through my video or somebody else's video, doesn't matter. But you can check it out, NEET 2027 complete preparation. There is a complete playlist over here. See, I have done the basics of geometry, right? Vectors, everything over here. Straight line, everything. So I think this lecture is not added over here. Oh, it's the derivatives and integration. I think I need to add them. But nevertheless, I will add it up very soon. Okay. So the derivatives part and the slopes and areas concept. Derivatives, areas, yeah, all that things. I have done it many number of times again and again. Integration, what is, derivatives, what is slopes, what is areas. You can just check it out in the video section or even in the live section. Just even if you put derivative, you will get it right over there. Yeah, derivatives and slopes, right? So we have done that multiple number of times. Yep, yeah, 100%. Hi, Hugh, welcome. Hi, Anasi. So we'll continue over there and I will just do a quick recap in case you might have forgotten it. No issues. Some of you might have forgotten. So we'll just do a quick recap. So derivative of any function means the rate of rate of change of that quantity, rate of change of that quantity, also called as the slope of the function or slope of the graph, slope of that particular graph. So if you have something like this, if you have something like this is some y-axis, this is some x-axis, and maybe you have a curve which goes like this. This particular curve which is there, which is your graph, might be of some function. Y is f of x. You tell me x, I will tell you y. You tell me x, I will tell you y. You tell me x, I will tell you y. So the slope or the rate of change of that will be nothing but y dy by dx, also called as f dash of x, also called as f dash of x. That is nothing but at that particular x, okay, whatever x value you have chosen, on that curve, you draw basically a tangent and see what angle does it make, let's say it is theta. Then tan of theta is called as the slope or the derivative of that function. Tan of theta is basically called as the slope or the rate of change or the differentiation or the derivative of that function at that location. So usually we will say that if you give me the value of x, I will give you the value of y. So if you give me the value of x, I will tell you the y at that location. So if I want to find the rate of change, you find the derivative of that thing, how quickly it is changing. It is the instantaneous value of change with respect to something. Do you remember this, everyone? Yeah, Hiho, Anasi, welcome, Rajshekar, Likshma, Saipriya, everyone. Yep. Do you remember this? Okay. And there were some formulas for derivatives which you should definitely remember. Like, for example, the derivative of x raised to n. What is it? Then derivative of a constant. Then derivative of x with respect to x. Then derivative of sine of x with respect to x. What is it? Then derivative of cos of x with respect to x. All these things, uh, basic derivatives you should know. There are multiple more formulas. I'm just giving you the standard ones. Derivative of log of x with respect to x. All these, what are the formulas? Well, for x raised to n, it is n into x raised to n minus 1. For constant, the derivative is 0. Derivative of x with respect to x is 1 only. Derivative of sine of x is cos of x. Derivative of cos of x is minus sine x. Derivative of e raised to x is e raised to x. Derivative of log of x is just 1 by x. These are some basic formulas which you should definitely know for solving derivatives. All right. Hi, Sham. Welcome, everyone. Fine. I hope you are able to recollect all these things. The exact opposite of derivatives is integration. Integration is also nothing but the antiderivative, antiderivative, antiderivative of a function, antiderivative of a function. It is also going to give me the area under the curve, area under the curve. So say for example, I have a graph of something. This is y-axis, this is x-axis. The graph goes something like this. Okay. And I just ask you, what is the integration? What is the integration? What is the integration of y with dx, which is basically the integration of f of x with dx? Because in this particular graph, my y is some function of x. I want to integrate it. When I want to integrate that function of x, the answer for that, the answer for that is basically, the answer for that is basically that thing whose derivative is f of x. So whatever thing's derivative gives me this function. So whose derivative, whose derivative, whosoever's derivative is f of x, that will come over here with c, which was, remember, the constant of integration, the constant of integration. So you have to think whose derivative is this. That's how you are able to do the integration aspect. Whenever there is constant of integration, it is called indefinite integration. Indefinite because that constant is always there. But when you put limits, when you have upper and lower limits, this is the lower limit, this is the upper limit, and you integrate this in this particular manner, then you just put substitute the upper limit first, then you substitute the lower limit next, and then you subtract them without the constant of integration. That is then called as the definite integration, which also gives me nothing but the area under the curves. Meaning, if this is the lower limit and this was the upper limit, in this particular region, whatever is that area, is given by the integration of that function from one point to the other point, lower point to the upper point, one location to the other location. What is the area under the graph? So this tells me the area under the graph, area under that particular graph from L to U, from L to U. What is there over here? It is basically the integration of the function or the antiderivative of the function, or that function whose derivative is going to give me back f of x. That is how definite integration works. There is no constant of integration. Just to remind you of the formulas quickly, remember integration of x raised to n dx, then integration of just dx, then integration of 1 by x dx, then integration of e raised to x dx, then integration of sine of x dx, then integration of cos of x dx, like that. So all you have to think is whose derivative is e raised to x. E raised to x is the derivative of e raised to x only, but constant of integration, because there are no limits. If limits were there, then you will put those limits and subtract them without the constant. That will give me the area. Whose derivative is sine of x? It is negative cos x's derivative plus c. Whose derivative is cos x? It is sine of x. So plus c. Same way over here, 1 by x is derivative of log of x. So log of x plus c. Derivative of whom is 1? It is basically x. So this will be x plus c, and this will be x raised to n plus 1 by n plus 1, the whole thing plus c. So the integration of x raised to n is this. Integration of just dx is x. Integration of 1 by x is log of x plus c, and same thing for the others. So these are the basic formulas which you should definitely know regarding integration. Is that clear? Hi future IITian, welcome. Yeah, welcome everyone. Yeah. Are you able to remember all these things? Okay. So these are the basic things that you will know. But if you want detailed classes, please go on to the channel and just search for derivatives or just search for integration. You can just put even derivative or even the word slope is also okay. If you just put slope, you will see derivatives and slope one shot. Every time I have done this, right? Basic maths. Now that you are aware of this, let's go and understand how derivatives and integration play a very important role in displacement, velocity, acceleration, and their graphs. Let's have a look at it one by one. Okay, starting off with velocity. We remember average velocity was big displacement upon the time taken. So the instantaneous velocity, so if you talk about instantaneous velocity, that will be basically a very small time, and the displacement done in that small time. How small the time is? The time is going to be extremely small, so it is dt. Instantaneous velocity, so no symbol of average or triangular brackets. That small displacement will be dr. R represents position, dr represents change in position. So dr by dt is nothing but instantaneous velocity. Some books also write it as ds by dt or dx by dt, whatever is convenient for you. You can use any symbol, but it means the same thing. So v is dr by dt is nothing but the instantaneous velocity. So as you can see over here, if you have a graph of example position with time, position with time, and let's say the graph is like this, and somebody decides to draw a tangent to the curve at some point, then whatever the tangent will make an angle with the horizontal line. So this is the tangent to the curve of position time. Then this will be exactly equal to tan theta, which is the slope of the position versus time. Position versus time. So how quickly the position changes with time, the rate of change or the slope of it gives me velocity at that moment. As you can see, if you draw a tangent here, it is upwards, so the slope is positive. Here, the tangent drawn is horizontal, the slope is 0. So velocity is 0 at this point. In this region, it is negative and again 0 and then again positive. So as you can see, in certain regions, slope is positive. Again over here, the slope is positive. Again over here, this particular part, slope is negative, right? So negative values over here, and in certain regions, positive values, and in certain places, absolutely 0. Because if you draw a tangent, it will be 0. So velocity is positive, then becomes 0, then becomes negative, then becomes 0, then again becomes positive. So the slope, the steepness tells me the value of the velocity. If it is upwards, the velocity is positive, means you are going towards the positive direction. If the slope is 0, that means you are not moving, velocity is 0, you are at rest. If it is downwards means negative value of velocity, that means you are going in the negative direction, that is towards this side, not on this side, left side. Okay, so that is the interpretation of those slopes, positive, negative, etc. Okay, KD Games, yes, the 9-month plan is coming very soon. Yeah, just give me a day, it's coming. Good evening, Nandini. Welcome aboard. I'm so glad, future, you are understanding every single aspect. See, like I said, integration is the exact opposite of derivative. So if velocity is the derivative of position, obviously, if you integrate this, you shall get displacement. So, or change in position. So, change in position, should be the anti-derivative of velocity. What is the meaning of antiderivative? It means integration. So integration of velocity should give me change in position. What is the meaning of change in position? Displacement. So it is nothing but going to give you displacement. So displacement is integration of velocity. So if I put over here displacement, integration of velocity, that means integral of v with dt from some moment to some other moment. Because integration is also area, it is also area under velocity versus the time graph. It is also area under the velocity versus the time graph. Meaning, if somebody gives me a graph like this, which is velocity with respect to time, and that graph is something like this, and I know this is a particular time t1 and I know this is a particular time t2. If I measure this particular area, right from here to here, that area under the graph is going to give me the displacement. That area under the graph is just going to give me velocity with time from one time to the other time, is going to give me the displacement of that particle. Very, very important. Very, very important. So displacement is integration of velocity with time with the limits. Sir, I didn't use the limits. Then what will I get? See, here I got displacement, which is nothing but change in position. I got change in the position. If I don't use limits, then I'll just get position in general. So if I just integrate it without the limits, then I will have some constant of integration. This will then just be position if there are no limits with indefinite way. So with definite way, I get the change of position. With the indefinite way, I just get position. Let me demonstrate this to you with certain examples. All these things, whatever we have learned. Let's start. Imagine x is t raised to 3 meters. You tell me time, I will tell you x. You tell me the value. Time is 1 second. Where are you? 1 cube. 1. Time is 2 seconds. 2 cube 8. You are at x is equal to 8. So you give me time, I can give you position. So with this, we can easily figure out what is the velocity. How? We just told velocity is a rate of change of position. Here my position is along the x-axis. So I will just use x with respect to time. So it means I have to take the derivative of t raised to 3. Now t raised to 3 is this kind of a function. This kind of a function, the derivative of it, the power comes outside and it is reduced by 1. So 3 will come outside and the power will reduce by 1. So this is the velocity. So that's it. Now I know v is 3t cube, 3t square, sorry. So if the question says what is the velocity at t is equal to 4 seconds, then all I need to do is velocity at 4 seconds means 3 multiplied by the value of time. I'll put it as 4 and square it. 4 square 16. 16 threes are 48. So the answer is 48 meters per second is the velocity at 4 seconds. Is that absolutely clear? Everybody with me? Can you start Waves chapter 12 syllabus? It will take some time, Nandini, but definitely it will come up very soon. Good evening. Yeah, great. So if you have understood till this point, if you have understood it till this point, if the question was find the average velocity till 4 seconds, then the answer will be different. What is the average velocity till 4 seconds? Then the answer will be different. You will first figure out the displacement. For that, you need the change in position. So what I'll need it, what is the position initially? This is the initial position. What is the initial position? So put time as 0. So 0 cube means 0 meters. Then you will find x final, which is x4. This is your final position. Final position. So you'll put 4 cube, which is nothing but 64 meters. And from here to here, you have taken 4 seconds. From here to here, you have taken 4 seconds. So the average velocity, which will be the displacement by the time, displacement is final minus initial by the time taken. 64 by 4, that is 16 meters per second. So this is average, this is instantaneous. Like you can see, they are completely different. Absolutely clear, my dear warriors? Okay, so this is how we can use the concept of derivatives in solving the question. Oh, nice, sir. So can you give me an example of the exact opposite, which is integration? Why not? Imagine I tell you velocity is example t square meters per second, and I am interested in finding out the position in general. So if I'm interested in just finding out the position in general and it is given to me, that listen boss, it is given to me that at t is equal to some 1 seconds, the position is chumma some 2 meters, some random thing I have told you. This is given to me and we have to find x in general. What is the position of that particle? So from velocity, if I have to go to position, as you can see, from velocity I have to go to position, I need to go to integration. So let's use this formula. Position is integration of velocity with an unknown, which is the constant of integration. So x is integration of velocity with some unknown. What is the velocity here? It is time square. Okay, sir. Time square's integration. Remember, we have to use this particular formula. X raised to n integration is x raised to n plus 1 by n plus 1. So we will use that particular formula right over here. So it will be t raised to 2 plus 1 by 2 plus 1, which is 3, and plus c over here. So that is x. But I don't know c. Don't worry. Something is given to me over here. So at t is equal to 1, x is equal to 2. So t is equal to 1, x is basically equal to 2 is given to me right over here. So 1 cube by 3 plus c. Perfect. So from this, what will be the constant? It will be nothing but 2 minus this 1 cube is 1. So 1 by 3 goes on the other side. So what will this be? 3 2s are 6. 6 minus 1 is basically 5. So 5 by 3 is the constant. So substitute back it over here. Substituting it back. Substitute it back. What do we get? X is equal to t cube divided by 3 plus constant is 5 by 3. That's it. That's the answer. So if you put time as 1, you will get x as 2 meters. Is that absolutely clear? I'm so glad, Shyam, you're loving it. Okay. So future, here the question was velocity was given. At this time, this is the velocity. At this time, this is the velocity. Can you find the position? So if you know the instantaneous velocity, so like I said, whenever you want to go to position from velocity, you need to integrate it with some constant, of course. So that is why I integrated the velocity. So velocity was t square. So I put it over here. T square's integration is this. But I don't know c. So to find that, this data was given. So I put x is 2 and time is 1. So from this, I got the constant, which is 5 by 3. So if I put the constant as 5 by 3, I get in general what is the position. Is that clear now? Perfect, everybody. Similarly, if it was with limits, then we can find the displacement. Let's say the question was find the displacement in first 2 seconds. That was the question. So what do we do? Displacement is integration of velocity from t1 to t2, definite integration, no need of limit, no need of constant. So time 1 is 0, first 2 seconds till 2 seconds, velocity is t square, that's it. So t square's integration is t raised to 3 divided by 3, and then I have to put the limits 0 and 2. So what will happen? Think about it. First put 2 instead of t, okay? Then put 0 instead of t, so 0 cube by 3, and subtract them. This is what definite integration does. You have to substitute the upper limit, then you have to substitute the lower limit, and then subtract the 2. So 2 cube is basically 8, and this is 0, of course. So the displacement is 8 by 3 meters in those 2 seconds. Understood, my dear warriors? Pakka? How to use integration and when to use derivatives. I'll give you a chart at the end that will make it even more clear, but I have demonstrated all these forward and backward problems. From position to velocity is derivatives, from velocity to position or displacement is integration or area under the curve. So, can you now think if I have to find out acceleration instantaneous, what will it be? So if I want to find the instantaneous value of acceleration, what could it be? In general, my average acceleration was In the denominator, how much time you have taken. So here the time taken will be very, very small. So the very small time which is taken, and in that time, how much is the change in velocity. So there will be a very small change in the velocity. Very small change in the velocity. So for average, it was a big change by a decent change. For instantaneous, it will be a small change in velocity upon small change in the time. So the instantaneous acceleration will be small change in velocity upon that small time interval. So this also means if I have a graph of velocity with respect to time, maybe that graph is like this or something. Then if somebody draws a tangent to this particular graph at any particular location, that tangent might be making some angle over here. This is theta. This is the tangent which is drawn. So this will be tan theta, which is nothing but the slope of velocity versus time, not position time. This is velocity with respect to time. That gives me the instantaneous acceleration. That gives me instantaneous acceleration. As you can see, if anybody draws a tangent in this region or in this region, the tangent goes down, slope is down, so it is a negative acceleration because value of the slope will be negative, so acceleration is negative. But if anybody draws a tangent in this region, whether you draw here or here, the graph is going up, so it is a positive slope or positive acceleration. Whereas if somebody draws something here or here, the tangent drawn will be horizontal, so the graph will have zero slope or zero acceleration at this location, or even at this location. So acceleration is zero. So negative slope, zero slope, positive slope, zero slope, negative slope. That's how it goes. That's how you can find the acceleration. Is that okay, everyone? Perfecto. Is this here? Come on, everyone. My dear NEET students, let me know quickly in the chat box. Sir, I'm a NEET student. Is that okay to watch JEE classes? Definitely you can watch the JEE classes, but only watch JEE mains level. Don't go beyond JEE mains. Okay? So you can watch. There is no harm because NCRT syllabus only is there. Number two, NTA is the same body which is making both JEE mains and the NEET paper. Number three, the difficulty of the NEET has been taken as much as the JEE only. In fact, much more difficult because in JEE there are only 25 questions in 1 hour. In NEET, you have 45 questions in 1 hour, approximately. So, if you think about it, right now, NEET physics is actually more crazier considering that most of the students wouldn't be taking maths versus JEE students will be taking up mathematics. So, considering all these factors in mind, how obviously it is wise that you can watch any of the classes. Okay, great. So Prajwal, which part you didn't understand, please let me know. Yeah, Sana, best guide for physics, as in you can use HC Verma for theory, DC Pandey, MTG books for problem solving, PYQ books from Disha publications or Arihan publications for previous year question papers. Okay, you can also use errorless and all of that for extra problem solving and everything. But if you want all in one, then better use Tattva modules with flashcards for revision, quick revision. Okay, links are there in the description box. Tangent drawn. Okay, see, whenever you have a graph, you draw the tangent slope or the slope of the curve is measured by tan theta. Tangent, the name only has come from that. So see, if that graph makes a big angle, then it has more slope, steep. So faster changes are happening. So imagine when you draw a tangent anywhere in the red zone here, the tangent is going down. Tangent is going down. So the slope is negative, meaning the acceleration is negative. If you draw any tangent in this region, like this, or like this, the tangent is moving up. So it is a positive slope. So acceleration is positive. If you draw a tangent here at the bottommost or the topmost point, the slope will be 0 because the graph will not make any angle with the horizontal line. So at those locations, the instantaneous, at that moment, acceleration is not there or it is 0. That is what the slope or the rate of change means. Is that okay, everyone? All right, perfecto. Right. Projectile motion, yes, we'll be doing here only. Yep, right. Perfect. Now, the exact opposite of this will be the antiderivative part. So, whenever you want to find the change in velocity, okay, whenever you want to find the change in velocity, that will be nothing but the exact opposite of derivative, which is integration of acceleration with respect to time. That's all. So change in velocity means like this. So this is delta v. Integration of acceleration with respect to time. So you have to take it with proper limits. Let's say t1 to t2. So this is nothing but area under acceleration versus time. This is nothing but area under acceleration versus time. So if you have some kind of a graph like this is acceleration, this is time, and the graph is like this. You take this particular time t1 and this particular time t2. In this duration, how much has the velocity changed? So you measure the area under this, that gives me the change in velocity. If you know initial velocity, you can also find the final velocity as well. So if you just want velocity in general, then don't do definite integration, then just do integration of acceleration. Don't put limits. That will just give you simply the velocity. So this is the indefinite way. If you do it the definite way, you will get the change in velocity. So definite always gives me the change. Indefinite always gives me some unknown which can be found, but it will give me the actual velocity. Just like in this particular part. Just integrating normally without any limits with a unknown constant gives me position, but with limits gives me the from here to here. Always from here to here, what will it be? A difference, a change. So it will be change in position. Okay, so that's how it works. So let me show you some examples related to that. Say for example, I tell you, boss, see, my velocity is example sine of t. Then can you find me the acceleration at t is equal to okay, some maybe I don't know, pi seconds. Can you find me the acceleration at t is equal to pi seconds? As we can see, we have to find acceleration from velocity. If you have to find acceleration from velocity, you have to take the derivative of it. So we'll take the derivative. So acceleration is derivative of the velocity. So derivative of velocity is nothing but sine of t. Sine of t is derivative. I have just explained it to you here. Standard basic questions, formulas. Derivative of sine is basically cos. So coming back over here, so derivative of sine of t will be cos of t. This is the acceleration. But I want to figure out at time is equal to pi seconds. So the specific value that I have to put is pi seconds. So instead of time, I'll put pi over here, and this will be cos of pi. So therefore, acceleration will be cos of pi. What is cos of pi? Which is cos of 180, which is -1. So -1 meters per second square is the acceleration. -1 meters per second square directly. Similarly, if some other question was there, let's say x is equal to maybe something like, I tell you, uh, log of t. Can you find acceleration? Can you find acceleration? Let's start. To find acceleration, I need velocity, but velocity is not given. Position is given. So first find velocity. How? Velocity is dx by dt. Oh, so x is nothing but log of t, and you have to find the derivative of it. I just told you derivative of logarithm is 1 by x or 1 by that thing. So it will be 1 by t, which is as good as saying t raised to minus 1. I just gave it to you right over here. These are the formulas. Derivative of log is 1 by x. So derivative of log t will be 1 by t, which is t raised to minus 1 when you take t on the top. Once you have velocity, now you can find acceleration, which is derivative of velocity, which means you have to find the derivative of t raised to minus 1. So minus 1 comes outside and t's power will be reduced by 1. So it will be minus t raised to minus 2, which is minus 1 by t square is the acceleration. So that is the acceleration, negative 1 by t square. So whenever acceleration has to be found from velocity, direct derivative, but from position, you will need the derivative 2 times. You will need the derivative 2 times. Is this absolutely clear? Okay. The exact opposite also you can do for integration part. So say for example purposes, if acceleration is given to you as something like t, okay, t meters per second square, can you find basically, let's say, the change in velocity in the first 3 seconds? Can you find the change in velocity in the first 3 seconds? Whenever you want to find the change in velocity, you have to integrate acceleration with the limits. So change in velocity will be, acceleration is already mentioned as t. This dt will come over here. First 3 means 0 to 3. T's integration will be t raised to 1 plus 1, which is 2, by 2. And I have to put the limits of 0 and 3. So first put time as 3, then put time as 0, and then subtract them. 3 square is 9. 0 square is 0. So this is nothing but 4.5 meters per second is our change in velocity. Is that clear, everyone? Yep. Clearo? Understood? Nandini, concentrate on the class. Yes, Nancy, perfecto. Amazingo. Can we move ahead? Sham, focus. Yes. Lecture chusu. Martlad beda. Okay, focus. Yeah. Now, to sum it up all over here, I can write it down like this. You have position, then you have velocity, and then you have acceleration over here. If you go down like this, then you have to do derivative dr by dt, which is also the slope of position versus time to give you velocity. From velocity, if you want to find acceleration, you do again derivative of velocity, which is slope of velocity versus time to give you acceleration. The exact opposite, from velocity, if you want to go to positioning, then you basically do integration of acceleration with respect to time plus c. Also, the change in position, is nothing but the area under acceleration versus time. So that's how you get it. From acceleration, if you want to go to velocity, if you integrate acceleration, sorry, this was not acceleration, this was velocity, guys. So sorry. So velocity is integration plus c gives me the position. Same way here, velocity will be given by acceleration's integration plus some constant. But if you want to find the change in velocity, you find the area under acceleration versus time graph. This was not acceleration, this was velocity versus, so that will give me velocity here. So if you remember this, your job is done. Main problem happens during the reverse part because it is integration. So please keep in mind, whenever change is asked, it is area, basically definite integration. When it is just velocity or just position, just integrate it normally with a constant. If you keep this much in mind, most of the things in the reverse process will be clear. This process is simple. It is slope or derivative from position to velocity, velocity to acceleration. To go from here to here, you have to take derivative 2 times. From acceleration to position, you have to integrate it 2 times. Okay, this chart is absolutely very, very important. Perfect. All right. Shall we do some questions coming up on your screen? Here it is. Number 1 question. Displacement of a particle is a plus bt plus ct square minus dt raised to 4. Initial velocity and acceleration are how much? So we have to find velocity and acceleration both. So velocity being displacement derivative. Therefore, velocity is the derivative of, what is that? A plus b into t raised to 1 plus c into t raised to 2 minus d into t raised to 4. So what will be the answer? A is a constant, so derivative is 0. B goes outside. Derivative of t is just 1 plus c. Derivative of t raised to 2 is 2t minus d multiplied by derivative of t raised to 4 is 4t cube. So hence it will become b plus 2ct minus 4dt cube. That is your velocity. Now let's figure out acceleration part, which is derivative of the velocity. So acceleration will be derivative of this number, which is b plus 2c into t raised to 1 technically minus 4d into t raised to 3. That is what it is. So acceleration will be, b is a constant, so derivative is 0 plus 2c is as it is, derivative of t will be 1 minus 4d, derivative of t cube will be 3t square. Therefore, in general, acceleration will be 2c minus 4 3s are 12d t square. Now substitute the values. They have asked initially. Initial means time is 0. So substitute time as 0. Time as 0. The only thing that you will get is just b, because this is 0, this is 0. So only b will be initial velocity. If you ask me initial acceleration, substitute time as 0. The only thing left will be 2c. So this is initial acceleration. So b and 2c will be the correct answer. Understood how to solve this question? Yes. Perfecto. Amazing. This kind of straightforward questions can come. With some practice, you will do it very quickly. Right now, initially, it might take some time. Okay. Don't get scared by it. Velocity is given. What is the acceleration? At what time is the acceleration 0? So question is on acceleration from velocity. So immediately think of derivatives. Acceleration is derivative of the velocity. So acceleration will be d by dt of 3t square minus 12t plus 6. So therefore, acceleration will be, 3 is a number coming outside. T square's derivative is basically 2t minus 12. T was raised to 1. So derivative of time is just 1 plus constant's derivative is 0. Therefore, acceleration will be 6t minus 12. As per the given information, acceleration of the particle is 0. So if the acceleration of the particle is 0, so 6t minus 12 is 0. Therefore, 6t is 12. Therefore, time is 2 seconds. So the answer is 2 seconds, which is option number A. Very simple, easy peasy. Welcome, Siddharthan. Welcome, everyone. Hi, Praveen. Hi, Siva. Welcome. Yes, 2 is the correct answer. Perfecto. Okay. Come on, everyone, give the correct answers now. Moving on to another question which was asked in NEET 2025 this year. Time is x square plus x. Come on, guys. Will you be able to crack this? Let me see. Find the acceleration of the particle. See, they have twisted and given the question. Usually, x is given as a function of time. Now they have given time as a function of x. That is what blew kids' minds. Got it? So this is a twisted question. Let's see how do we do it. Time is given as a function of x, sir. How the hell do I find acceleration now? Because this is x square plus x. You cannot just do it. Okay, first let me write it down. T is x square plus x. What will happen if I just take the simple derivative over here? So this will be dt by dt is d by dt of x square plus x. Derivative of t with respect to t is 1. I've just taken derivative on both sides. This is derivative of x square plus I have derivative of x with respect to time. I have an idea now. I can't take the derivative of x square directly. So how about writing it derivative of x square with respect to x and multiply it with dx and again put dx by dt over here. Why did I do it like that? Because I know one thing over here for sure. This number that you see and this number that you see, those are nothing but velocities. Velocities. Yes, dx by dt is nothing but velocity. And this guy, I can just take the normal derivative. X square's derivative with respect to x is 2x. I can't find the derivative with respect to something else. Always it has to be the same number. That's what you would have seen even here when I explained these formulas. Same number, same number, cos x dx, sin x dx, everything with respect to the same thing. If it is x, it can't be y or t or z or something like that. So by that logic, obviously I wanted, instead of dt, I wanted dx, but I can't just magically write dx there. So if I divide by dx, I have to multiply by dx. So equality is preserved. This is also called sometimes as the chain rule of derivatives. And then my equality is the same. I mean, dt is still preserved. Dx anyways cancel. But the advantage is, if I just look at this much part, I can find the derivative, which is 2 into x raised to 1. And this number is just velocity. Perfect. So now I can take out velocity common from both of them. So velocity, if I take it out as common from both of them, what do I get? I see 2x plus 1 is equal to 1 over here. Is that right? So therefore, what will be the velocity? Velocity will be nothing but 2x plus 1 whole raised to minus 1. Whole raised to minus 1. Everybody fine till this point? This is nothing but your velocity. But rather than doing all this, I have an idea. Why not take the derivative here only? Yes, why not take the derivative here only? So imagine I take one more time derivative over here and derivative over here. On left hand side, I have the number 1. On the right hand side, I have 2x into velocity and plus velocity over here. Just check this out. This is what I have on the right hand side. Now let's see what happens. Derivative of number 1, which is a constant, so answer is 0. Here I need to be little bit careful. There are two numbers being producted, so I will put 2 over here, and derivative of x multiplied by velocity with respect to time plus derivative of again velocity with respect to time. What will this be? Let's understand. Bring this over here. So this will be minus derivative of velocity with respect to time is equal to 2 into, whenever you have product, the product rule says take the first function like x and then take the derivative of the second number, then take the second function and then take the derivative of the first guy. That is how you will find it. It is called as the product rule. Derivative of uv is uv dash plus vu dash, or first into second derivative plus second into first guy's derivative. Now guess what the dv by dt is? The rate of change of velocity, which is nothing but acceleration. So a lot of places acceleration is there. Even this is nothing but acceleration. This is v. Dx by dt is nothing but velocity right over here. Okay, so perfect. So we got acceleration in terms of x and velocity. So if you want, you can write acceleration is -2. Okay, and -2 multiplied by x into a, -2 multiplied by x into a, -2 times of v square. So bring this guy over here. So we'll have to go on to the next slide. Just check this out. So it will become a plus 2 times of xa is equal to a plus 2 times of xa is equal to minus 2 times of v square. Take out a common, so it will be 1 plus 2x is equal to minus 2 into v square. But if you look at this one, this particular equation which we had written down over here, which said, where did it go? 1 is equal to 2x v plus v. 1 is equal to 2xv plus v. If you look at this equation, from this, if velocity is taken out as common, so it will be 2x plus 1 is 1. Therefore, velocity is 1 by 2x plus 1. Therefore, velocity is 1 divided by 2x plus 1. How about substituting that velocity over here? So it will be nothing but your 1 by 2x plus 1 the whole square. This whole thing, the square. I've just substituted the value of velocity from here. I hope this is absolutely clear. Now, just write down what acceleration will be. -2 is there. This is 2x plus 1 square. This is brought down here, 1 plus 2x. What will this be? -2 by? This is 1 plus 2x whole cube. So that is the acceleration, and you can see that is there right over here, -2 by 2x plus 1 whole cube. Option number D. So this kind of question, such mathematically intense, came in the current NEET paper. Do you understand now why I'm saying it's like JEE mains only? Yes, Nandini, what doubt you have? Yes, Sushil, the difference between a derivative and integration and what is it? I can't understand. Sushil, please watch this particular classes. It's there. Please watch this. Derivatives and slopes. Okay, derivatives and slope. Please watch this class. It is very important. I have taught everything. If you want to start with this. Basic maths algebra, then go to basic maths geometry, then complete derivatives and slope. Okay, complete. It's proper 2-hour lecture on what is derivative and what is integration. Okay, Susil, after that, if you tell me that I have a doubt in derivative, I will be surprised. You will not have. Watch it. It will just cost you 1 day. Properly sit with a pencil, pen, paper in front of the screen and watch it. Okay. So, in this particular question, as you can see, position was not given, time was given, and you had to find acceleration, which is a very unconventional way of solving the question. So what we had to do is we have to think also very differently. Time was given. So I thought, why not take derivative? So derivative of t with respect to t is 1. So I took this guy's derivative. Derivative can't be taken for x with time. So I divided with x and multiplied with dx again. So nothing is changed. But I can do this derivative easily. X square's derivative is there. This is velocity. Dx by dt is velocity. If I think carefully, then velocity can be taken common. So 2x plus 1 is 1. So 2x plus 1 can be taken here. So this is velocity in general. But that is not asked. Question is acceleration. So then I thought, why not take the derivative of this guy? Derivative of 1 is 0. I have to take the derivative of this whole thing. Because there is a plus, I separate the derivatives. But here there are two things multiplied. So I use the multiplication rule of derivatives, which is take the first guy, second guy's derivative, then take the second guy, and then the first function's derivative. As we proceed, we noticed derivative of velocity is acceleration, derivative of position is velocity, derivative of velocity is again acceleration. So I just wrote it down properly. I rearranged this equation to write acceleration common, and then I put the velocity over here as it is. The value of velocity was this one. I put it over here. Okay, please understand this whole thing square was as it is. I just substituted the value of velocity here, and solving this, I just saw this is the acceleration in terms of x. Just went on proceeding. Cool. Hi Nimaleswaran, welcome aboard everyone. So these are the kind of questions that you can be asked, guys. And there was in fact one more question which was asked, ratio of initial velocity to its initial acceleration in NEET 2025 this year. So look at this. This equation, tell me, is it not the same as this question? A, instead of A, alpha is there, instead of B, beta is there, instead of C, gamma is there, instead of D, delta is there. Initial velocity and initial acceleration. Initial velocity is B, initial acceleration is 2c. So it is beta and 2 gamma, if you notice. So it's the same question which has been repeated. If you notice, yes, it's the same question which has been repeated. So I am pretty sure you will be able to solve this, but I want you to solve this now as homework. Will you be able to do it? Yes or no? Put fire emoji in the chat box. And where will the answer be? Answer should be in the comment section. I want everybody to comment the answer. Easily you will be able to do it. Okay? Perfect. Clearly understood. Awesome. Awesome. Great. Now let's see some graph-based questions. Let's start with some position time graph-based questions. Here is the first one. The position graph for positive acceleration is, think, position graph for positive acceleration. We want the value of acceleration to be positive. That means dv by dt should be positive. But what is velocity? But think about it. What is velocity? Velocity, which you see over here, is nothing but the slope of position versus time. This should be positive. This should be positive. That means the derivative of the slope should be positive. What on earth is this? Derivative of the slope should be positive. I thought slope only was the derivative. Correct, slope is the derivative, but derivative of derivative, that's what I'm asking. Oh, so if somebody measures the slope of x versus t, let's say it is like this, then after some time, maybe the slope becomes more, and after some more time, the slope becomes more. So the slope value is increasing. That's when the derivative will be positive. But if, imagine, first the slope was like this, then it is like this, then it is like this. The slope is decreasing. So the rate of change of slope is going to be negative. So what this means is that the rate of change of the slope of position versus time is basically positive. This means that, simply put, the slope of position versus time is increasing, is nothing but increasing. That's the meaning of it. If the slope of anything is positive or the rate of change is positive, that means it is going up. If the rate of change is negative, means it is going down. So slope of it is going up. As you can see over here, if I draw a tangent, the tangent drawn is going to be a constant. So here 100% the slope is constant. It is not increasing, right? Here also, in fact, if you draw a tangent, here also I can say that the slope is constant. The slope is constant. If you notice this particular graph, the tangent here, then here, then here, the slope is reducing. The slope is reducing. So acceleration will technically be negative, but it is only this part where the slope is increasing. The slope is increasing. So therefore, acceleration will be positive in graph number B. Is this clear? A pure question on graph, which was asked in NEET 2022. Isn't it amazing, guys? Absolutely clear about this. Let's move to another question which was asked in NEET 2022. Displacement time graph is given, their angles are given, the ratio of the velocities are. Well, whenever we have displacement time, velocity is nothing but derivative of the displacement, which is nothing but the slope of the displacement versus time, and slope is nothing but tan of the angle made by the graph. So here what we need, velocity 1 by velocity number 2 will be tan theta 1 by tan theta 2. You just have to take the tans of both the things. One is 30, one is 45. So tan of 30 degrees by tan of 45 degrees. Tan 30 is 1 by root 2. Tan 45 is 1. So it will be 1 is to root 3. So 1 is to root 3 is option number A. That's it. That is the answer. One graph slope is tan 30, other graph slope is tan 45. Tan 45 is 1, tan 30 is 1 by root 3. Yes, 1 by root 3, perfect, Ansi, perfecto. Amazing, Siva, perfecto. Let's move to the next graph, which is velocity time graphs. Velocity versus time graph. Yeah. So, my dear warriors, in this particular graph, the distance covered in the 4 seconds is asked. Whenever question is on displacement distance from velocity, it's nothing but the area under the graph. So the displacement is area under velocity versus time. So you just have to find the complete area, nothing else. So let's do part by part, one by one. Like this guy's area, it's a triangle, right? It is half into the base into the height. So 20 by 2 is 10. Then we can see that there is one more triangle right over here, which will be half. Base is again 1. Height is only this much, which is 10, which is basically 5. Now, many of them are nothing but squares or rectangles. Like, for example, if you take this entire rectangle over here, the height is 10 units, the base is 2 units, 2 to 4 is 2, so this is 20. Similarly, if you look at this particular rectangle right over here, how much will that be? Base is 1, height is 20, so 1 into 20, which is 20. So you have to add up all the areas, that's it. So first area here is 10, next is 20, next is again 20, and the last one is basically 5. So 20 plus 20, 40 plus 10, 50. So this is 55. So 55 is the right answer. Is that clear? How to find it out? Just simple area addition. Yeah, not 60 meters, 55. I think some of you missed something. It is 55, which is the right answer. Okay. And guys, tell me one thing. Sometimes this might also happen that the graph is something up and something down. Then be careful. If this area comes out as something like 20, and if this particular area comes out, let's say, as 5, don't tell that the total area, is 20 plus 5. That is wrong. It is not 20 plus 5 because this area is below the horizontal line. This area is below that horizontal axis. Then that area has to be considered as negative. So always put a minus sign here. So technically it is 20 plus negative 5. So hence the total area will be 15 units. So whenever the graph goes below, be careful of the negative areas. Luckily for us, the graph did not go down here anywhere. So we have always added. But if at all it would have gone down, then I should be careful to take the negative values. All right. Let's take up another question on your screen. Velocity graph is given. Which acceleration is the best representing that velocity? This is how the velocity graph is. Let's understand how it is changing. Here, the velocity is constantly zero. So if velocity is constant here also in fact velocity is constant. It is constant. So what will be the derivative of a constant? It is zero. So acceleration is zero. So this part and this part, acceleration is zero. As you can see in this particular segment, my derivative of velocity, which is the slope, will be positive. The slope will be positive. That means acceleration is also going to be positive. And if you see in this part, my slope, which is derivative, will be negative. So acceleration will be negative. So 0, positive, 0, negative. 0, positive, 0, negative. There is only one graph which is here. See, this is negative value. As you can see over here, this is negative value. Then you can see over here, this is the positive value of the acceleration. This is the positive value of the acceleration. And it is 0 for some time, becomes positive, again 0, and again negative. So this is how the graph is. It is abruptly changing. 0, zoop, positive, 0, then negative. Abruptly it is changing. Okay, it is abruptly changing from here to here. Suddenly it started accelerating, suddenly stopped accelerating, suddenly started negative acceleration, and then suddenly stopped accelerating again. So that is the graph. Yep. Option number C. That is the right answer. Can you see that, everyone, with me? Very good, Praveen. Very good, Nandini. Very good, Siva. Awesomeness. 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 You guys are really doing well. Next questions on acceleration graph. Yeah, we are doing all kinds of varieties, guys. Acceleration graph, find the change in the velocity of the particle. What is change in velocity? If you remember that chart, that beautiful chart which I told you, change in velocity is area under that graph of acceleration with time. See, that is why that graph, that chart is very, very important. Change in velocity is area under acceleration versus time. Okay, first things first, this particular area, let me calculate it. It's a triangle. So half into the base, which is 4, height is also 4. 4 4 is 16, by 2 is 8. This particular area is below, so be careful about it. This is going to be negative area. So this is a triangle whose base is 2 units and the height is 4 units. 2 to cancel, so it will be minus 4. So it should be minus 4 over here and then 8 over here, and both of them are being added. So 8 minus 4 is nothing but 4 meters per second is the answer. Yes, that is correct. Please do not add 8 plus 4 because then the answer will be 12 and many students will mark C, which will give you negative marks. So be careful whenever the graphs have negative areas, you need to account for the sign. It is always below. Yes, it is basically 4 meters per second. No, it is not D. Be careful. The question is from 0 to 6 seconds, not only the positive area. So many people also mark D. That is right, wrong. Okay. Is that clear? Very good. Amazing. So that was the last question for today. So these were the kind of questions which come in non-uniform motion where acceleration is not constant. And whenever acceleration is not constant, use derivatives, slopes, or integration or areas. You can't use kinematics. Yes, you can't use kinematics. Kinematics, what is the rule? Acceleration must be constant. Then it is simple. No need of derivatives and areas and all of that. Direct V is U plus AT, S is UT plus half AT square, V square is U square plus 2S, which we did in the last 2 lectures. Clear? So we'll meet for projectile next. Yeah, on the channel. Have a great time. Yeah, take care. God bless you all. All right. Bye bye.